So, hello, my name is Charles Williams. I'm with Earth Activist Training, and this is a little session on flood mapping. And I'm here in Nova Scotia, the traditional land of the Mi'kmaq people called Mi'kmaqi. I like to acknowledge the place that I present from. And if you're feeling called, feel free to put your name and where you are, either the traditional territories or the colonial territory that you're in. It's always nice to know where people are at. So where we're going to start out today is in where I am in Nova Scotia. So I'm going to give an example of doing a flood map for where I live, which is Halifax, Nova Scotia. And as we go along, if you have any questions, feel free to unmute, or either you can raise your hand. At the bottom of the screen, there's little icons. You can kind of push the little button for raise hand, and you'll pop up on my screen, and I can answer your question. But if you can't find that, you can just unmute and say, excuse me, I have a question. And we'll answer questions as we go. There'll also be some time at the end for question and answer. So, but if you're getting lost, feel free to stop me, and we will do questions as we go. And I'm going to give you a little sheet you can follow along with in the chat. So here is what we're going to be doing today. I'm going to put this in the chat so you can see it. Follow along. There we go. On. Okay, so where we're going to start is here in Halifax, Nova Scotia. So I'm working in a program called QGIS. It's a free open source mapping software. It has a lot of functions, like it does a whole lot of things, but we're only going to focus on using just a few of the functions to do mapping for floodwaters. And I'll work you through those. So the first thing that we have to do to map our floodwaters is we need to decide where we're going to do it. So in my case, I am here in Halifax, Nova Scotia. So I'm going to find myself on my base map. And I'll have to go get some data. So in the world of mapping and especially GIS mapping, you don't start with any information. Having the program QGIS doesn't mean you have any information to work with. It doesn't inherently have like all the maps of the world. You need to go and get those. So the way in which I go and gather my data is I go online and I search up my local political entity that I live within. That can be your city, that can be your county, it can be your state, your province, or the federal government, the US, Canada, Mexico, depends on where you live. So you search up, usually I start with the smallest one. So I usually start with my city and then go to my like township or county. So in this case, I go and I search up open data for Halifax, Nova Scotia. Open mapping data. It has a portal. Cities use maps all the time. They have a lot of map information. States have a lot of map information. Countries have a lot of map information, and they share that. So I can search the things that I want. So I know for this mapping application, I need 3 things to figure out floods. I'm going to start with buildings. So I need I need to know where all the buildings are because it kind of helps me figure out what's going to flood, which buildings will and will not. So I'm going to look up buildings. I'm also going to need 2 terrain layers, and I'll explain those in a second. So buildings, first thing that comes up when I search for it in the local portal, each of your municipalities, states, provinces will have a slightly different layout to what these look like, but there's usually a way in which you can search for what you're looking for. So buildings, I download that. I've already done that because it's such a large file, it takes some time. I'm not going to do that right now because then we just sit here and wait for my computer to like download something. The other thing that I am looking for is a DEM. This word right here, DEM, it's an acronym for Digital Elevation Model. I'm looking for one of those for where I'm working. And I'm also looking for a DSM, a digital surface model. So I see here's a LiDAR DEM 1M, 1 meter. I'm in Canada. They measure things in meters. So I would download this one. So I've done that. I've got, and this basically says, where's the surface of the Earth? Where are the contours of the Earth? And where are the low spots? Where are the high spots? And this is going to help us figure out where the water rises. When it rises up, kind of where does it go? So this digital elevation model is really important for this. So we get our DEM, and I'm looking for a DSM also. So I scroll down here, seeing if I can find one. Oh, there's a DSM, 1 meter like the one before. So I'll get my DSM digital surface model, which is a little different, but I'll explain it when we're in the mapping software. It'll make a lot more sense. You can see what I'm talking about. So we have a DSM, a digital surface model, a DEM, digital elevation model, and we're going to have our building footprints for wherever we live. And that'll give us enough to get started. So I have downloaded those things here. I have downloaded my building footprints, my DSM, my digital surface model, and my DEM, my digital elevation model. And this is what they look like. The digital elevation model, when it comes in, it looks like this. It looks like a big gray blob, and it takes up a bit of space. It's like in a big area. It's a big file, and we're going to work with that. The DSM, the surface model, looks very similar. It is also kind of a gray, gray to black tones. And this is a large area here, a lot of data. And then I'll leave one of those up so you can see it. And then we have buildings. Buildings come in as the footprint, like the outline of where our buildings sit. So you can see all the buildings that come in. And in my case, they've come in as green. They come in different colors depending on what the program chooses. It's kind of random what color they come in. But every building has a little footprint of kind of where it sits. So we get these 3 files downloaded. They're big files. And to work with them takes a fair bit of computing power. So what we're going to do is we're going to trim them down to just the area we want to focus. and it'll make it a lot easier to work with. Instead of working with this, if you've ever had on a table where you like roll out big pieces of paper or big maps and you're working with them and they're hard to work with because they're too big for your table, same is true digitally. If you have really big files, they're really hard to work with. So we trim them down, and that's what we're going to do before we start working on them. They'll be a lot easier to work with once we trim them down. So I'm going to work with one of them at a time. I'm going to start with maybe my DEM. I'll start with that file. I want to trim it down. I want to trim it down so that it fits just what I'm looking for. In my case, I want the peninsula, this black peninsula I live on. I want to look at that. I want to look at where I am and where water might come. In the peninsula, I live right on the ocean. So if water rises, like sea level rise happens, it'll affect this peninsula. So I want to look at that. So I get on my screen what I want to look at. Once you have what you're going to look at, we're going to start to use the tools that are out there. So first thing I'm going to do is on the layers that I've imported in my kind of layer panel here on the left, I'm going to right click on them. And we're going to go to export. So I'm going to save it as. And basically what I'm doing now is I'm going to take this big file I have, I'm going to save a small piece of it on my computer so that I can work with it. So I'm going to save it, I'll give it a name, something like maybe Halifax DEM, because I need to know what it is. It's 1 meter, I like to know that, 1 meter, and I'm going to call it clip because I'm going to have kind of clipped it into a smaller piece. So I decide the name, I decide where I'm going to save it on my computer. It's important to remember where. I'm going to save this in, a folder on my computer. I've got a flood mapping folder. I'll save it in there. So I'm going to save this thing, and I'm going to clip it by the canvas extent, which means that I'm just taking the piece that I can see on my screen. So I'm going to cut out all the rest of it and throw it away. I'm just going to keep that one small little piece. And while I'm doing that, I'm going to look through here, and I'm going to set this thing that's CRS. I'm going to notice what that one is. I want them, all the things I clip out, I'm going to have them be the same thing. For you, you might just want to, whatever the first one you use, you might just want to use it for all of them and just leave the first one and just make sure that all the ones you do later than this match. In my case, I know which one I want. And I'm going to do 3.7. I'm going to do the Lambert conic because of where I am. It's a better map to do for where I am, and I'll save that. And I'm going to hit run. I'll hit OK, and it's going to save that. And it's going to open it on my computer, on my maps here. I'm not going to do that because it takes some time. So a couple of these things, I'm just going to tell you what I did because it just takes time for it to process through, and I want to keep moving versus just sit and watch my computer process things. So I've done. I did that to make my DSM flood map here. So you can see here on the left, I saved my LiDAR DEM to a Halifax flood map DEM. And what we're going to do is we'll look at the difference between the two. Wait a second. I'm going to change this back to what it was before so they look the same. There we go. So what I've done is I had this big file, and what I did is I clipped it out so I only had a piece of it. So I just clipped out this little piece so I can work with something smaller. So that's what you're going to want to do. First step you're going to do is get your data, get your layers, your DSM, DEM, and building layers, and each of those you'll export out onto your computer to a smaller canvas extent, the size that you want. So now I have my 3 layers that I've clipped out to be, so I have my building layer, I've got my DSM layer, and I have my flood map layer. I've got all 3 of those. Now, I want to explain what the difference between a DSM and a DEM are. A DEM, a digital elevation model, is the surface of the Earth. And the best way to see this, I'm going to change it to be a hillshade so we can kind of see it. It's the surface of the Earth. It is what the ground looks like if you were to strip off all the buildings, all of the trees, all of the telephone poles, and all you had was like the surface of the ground. And in this picture, you can see that it's fairly flat where I live, but there's like this hill here. This is a hill. You can see over here, there's more of a hill over here. It's kind of these areas that are a little raised. That circle is a pad that they've actually like excavated the earth and have like a water tower sitting on. It's like a big metal water tower there. You can see the footprint to houses and the roads because they're often, have graded the roads and they're slightly below the surface of the neighborhood because all the water runs away from the houses to the streets and in the gutters and stuff. So you can see the roads in there, but it's a fairly flat city. That's the digital elevation model. Sometimes they're called digital terrain models, DTMs. The DSMs, when I do those for hillshades, what they show us is the top of everything. Like it's like draping a blanket over the whole city, and I see the top of every tree, the top of every building, the top of everything. So it's just the surface of, the top of everything that's there is what we're seeing. So when you look at a DSM, what you see what the surface of everything looks like from the high point. And those are important because we're going to do 2 different things with them. So this is what you got for a DSM. So we have these 2 different ones. You have to kind of keep remembering what they are. One's the surface of the Earth. One's the surface of all the things that sit on top of the Earth. Once we have these files, and we're ready to go. For me, the first thing that I'm going to do is you can see it's all this gray and black. There's some areas that are white. The white areas are ocean. There's no surface there. The surface of the Earth goes below it, and like there's no data in that layer. So I'm going to add some data there. And it's important to add that data because I want to say that's water. And right now it says it's nothing, but I know it's something. It's water. So we're going to add some data. So I'm going to do a filled data. To add in data, if you are on your DEM and your DEM rasters, if you're missing them, you'll add data. So on our processing, we're going to look for tools. Processing tools, this area, this is where you find all the tools you get to work with. And we need to add to the no data. So where it says no data, I'm going to fill those no data cells. So I'm this tool pops the little box up. Can people see the box? I'm just making sure you can see the pop up and it's not hiding behind something.
Yeah, we can see it.
Great. So we've got the filled no data. So we're going to fill the data. I will send, you'll have a recording of this. I'm going to send you a document that kind of outlines the steps I've gone through, just so you know. I'll be sending that along with the recording when it's over. Raster fill node, and I want to fill, I know which one I want to fill. Halifax DEM flood map 1 meter. That's the one I clipped out. Make sure that's selected here in the top. Leave the band gray. I'm going to fill value instead of 1, I want it to be 0 because I'm going to fill it and say that the elevation of the ocean is 0. It's like the lowest spot. And then I'm going to go up from there. So I'm going to run that as 0. And yep, got all of our pieces in there. And we'll just save that. So it runs. This should be pretty fast, so we'll do this one. This is why we cut it down. If I were to do this on the big DEM that I had before, this could take 5 minutes. By cutting it down, it takes a lot less time. Okay, so we've got our output raster here for that one. Is there a question in the chat? Terry had a question. Can I show Oakland, the Bay Area in California? I can. I could go over there. Getting all the layers and getting it set up would take some time. So I'm not going to go there right now. But to do Oakland, you do the same thing. You'd go to the city of California or Oakland. You'd search open data, and you'd start to gather these pieces of information. And then you go through very similar steps to try to do this one. Maybe at the end, if we have a moment, we can go jump over to Oakland and take a look at what's going on over there. So we've got our output rasters, which doesn't, it's okay if it just looks gray because this is just a step on our way. So from this, so basically it's filled in all the white spots. I could restylize that so it looked like the other ones. We'll turn that to hill shade just so it kind of looks like what it did before. Now you can see instead of that white around, it's got gray around it all, and it's all very flat. It's all very even because the ocean is flat. So we got our output raster. Now we're going to work with that output raster, and we're going to do what we call reclassification. And reclassifying is a way in which we're going to take all the information in this layer and simplify it. So we're going to go back to our processing toolbox. And in our processing toolbox. And we're going to look for the raster reclassify. And we're going to reclassify by table. We're going to use the table to do this. And what we're basically doing is a raster is a type of map that has a bunch of little squares here to zoom in. It'd be like a pixels in a picture. Like there's a bunch of pixels, and each pixel has a value. Right now, each value is like elevation. It tells us how high or how low that pixel is compared to the one next to it. We don't need to know all the values. We're going to simplify these values just to a few that we want to work with. So to do this, we've chosen output raster, which is the layer we just created. So that's the top choice, like what raster we're working with. We're going to reclassify by table. So we're going to click the 3 little dots here on the side. We're going to add a row, and we're going to say all elevations that are, I'm going to pick a really low number, like -10. Anything, a -10 to 0, this is 0 feet. So anything from like negative feet below sea level to 0, I'm going to set it as a value of 0 feet. I'm going to say, okay, so anything that's between 0 and 1 is going to be called 1 foot of elevation. So this is like if floods came in for 1 feet, this would be an elevation. Anything over 1 foot over the basic surface is 1. Then we're going to go anything from 1 to 2, we're going to call that 2. From 2 to 3, we'll call that 3. So this is each, like, what happens if we had 1 foot, 1 meter of water rise? What if we had 2 meters of water rise? What if we had 3 meters of water rise? So like, that's what these numbers represent. And if we go from 3, 3 is probably enough. 3 meters of rise is pretty significant where I am. Like, that's 9 feet. Water went up 9 feet. That'd be pretty big. So 3 meters of rise, what we're working with for this example. For you, you might do it slightly differently depending on what your water change might be. And I'm going to say the maximum. I'm just going to put some number that's way above anything else in this document. Just kind of collects all the other ones to say this is above 3 meters. So I'm going to say like 500. So 500. And I'm going to say anything from 3 and above. I'm just going to call that 4, and that'll just be everything above that. So we'll run this. It's going to give us an output. In this particular step along the way, they're reclassifying the raster. If you don't live at sea level, let's say you live inland and you're looking at rivers or lakes or something that you're like, oh, I'm by a lake, and is it going to come up, or a river is going to come up? Instead of using zero is like 0 elevation, which is sea level. But if you lived, let's say, up in the hills, you're like 1,000 feet above sea level or something, and your lake was at 1,100, you'd start at 1,100, and anything below that would be 1,000, 50 to 100. You'd say that was 1,100, then you do 1,101. So you would use whatever elevation matched where you lived. Does that make sense? As your kind of increments. So we're starting at 0, so we'd 0, 1, 2, 3, 4. If you lived at 1,000 feet elevation, you do 1,000, 1,001, 1,002, 1,003 to go up. So for what you'd put into that table. Okay. Great. So there we go. We got our raster. Does not look all that exciting, but we're going to style it. And in styling in QGIS or ArcGIS, it is when you decide what it's going to look like so that it looks like something that makes sense. So we're going to stylize this layer. So I've made sure I have my reclassified layer selected. It's blue here on the left. I'm going to come in here and I'm making sure at the layer styling. So what I did is I hit the little button. I'll show you what I did. Right here below the word layer and above my layers that you can see here on the left, I hit the little left-hand button. It's tiny. I guess it's supposed to look like a paintbrush and a palette. It's really kind of hard to see. It's like a couple of colors and a little line. So layer styling. We want to make sure we've chosen the right one. Reclassified layer. That's the layer we're working with. We're going to change that one from single band gray. We don't want it to be gray anymore. We're going to go to single band, what they call pseudo color. So we're going to start to have some colors that we can work with. And coming down, I'm going to leave band 1. I'm going to make sure my minimum is at 0. That was the lowest number that I had in my chart. And maximum was 4. That was the highest number I had in my chart. I'm going to make my interpolation exact because I want to use exact numbers. I don't want to use partial numbers. I've chosen a blue color ramp because blue is like water. So we'll leave that what it is. Label precision, you can leave that alone. In the bottom, we have the mode here. We want to make sure our mode is equal interval. And we have 5 classes. 0, 1, 2, 3, 4. There's 5 distinct groups we're working with. Now we've got a useful kind of map to begin us off. When you first do this on your own, you'll notice that it might come in different colors. It might come in with all crazy colors that make no sense. You can just click on each of these little squares and change the color to what you want. So if it's not coming in the color, you can actually just like kind of change those to be colors that you want. So once we've got this, we can start to look at some of the things that are going on, because now we're starting to get some really useful information. How's this? I'm going to turn my building layer back on here for a second. I'm going to bring it up here. Okay, so you can see Actually, I want to change one thing I don't like in here. Back to reclassify. You can see the ocean is white right now. I find it a little confusing. So I'm going to change the ocean, the 0 level. I want that one to be dark blue. Okay. And I want to change the top level one. I'm just going to remove it because I don't need that one. Now, what we've got is we can see our buildings. Let's put our DEM back on. There we go. Great. Now, we can see our city with our buildings. We're just getting there now. We're getting close. And I've zoomed into the edge of the ocean. And as we go look at the ocean, we can start to see where it inundates this blue color, which is the ocean, and then it starts to come in, and you can see the different areas that the water will start to come in and what buildings are going to be impacted. So we're starting to get an idea of what this flood map is going to look like. Some buildings will have areas that are on one side is higher than the other, so it gets more water on one side than the other. We're starting to get our map together. So in our map progression, the lightest blue are the areas that'll flood first, and the darker blues are the ones that'll flood last. So this light blue area here is where we're going to see water first, and these dark blue areas where we see water later. Like this is 3 meters of rise, where this lighter colored over here is like 2 meters, and the lightest colors out here are 1 meter of rise. So you can start to see where the water is going to come in as it goes up. It comes up. Okay. Now, the next thing that I'm going to want to do is, again, moving from this raster we just did. We had this reclassified raster. It's starting to help us out here. But we're going to shift it a little bit and move it from this raster format, which is a format that we have less ability to work with. And we're going to turn it into a vector format. So rasters are like photographs where every little point is a pixel and it has a value. A vector, it just has areas that are what we're looking at and areas that are outside of that are anything. So we're going to shift to a vector, which will allow us to see this in a way that's more useful. So the way that we do that is we're going to go to the top of our screen where it says raster, which is what we're working with. And we're going to go to conversions. We want to convert a raster, which is the format that it's in. We want to convert the format of this map into a vector where we can work with that a little more to visualize what's going on. And the way they call it polygonization, or raster to vector. So we're going to choose that one, polygonization. So polynize it. We make sure we've got the reclassified rasters when we're working on. We have, we'll leave this field DN, just leave that as a DN. Need to have it there. And yep, and that'll be good. We'll just save that. If you're interested in learning more about this style of mapping, QGIS and digital mapping, I do a class that kind of goes over the details, like how do you navigate through QGIS and what other things it can do. It can do a lot of things. It can make contour lines. It can help look at like different types of soil types or cover types. You can start to visualize, doing designs and plans. And once you get used to it, there's many things you can do with QGIS around looking at things that have a spatial component. Whether it's things like sea level rise, where you look at where water moves, you also can look at things like crime rate and like how it affects neighborhoods, things like that. So you can do a lot with this program. Okay, I'm not really excited about the purple of our vectorized, so I'm going to again change the how it looks. I'm going to turn off raster classification. Vectorization, I'm going to go to stylizing again. So I'm going to change the style of how it's being depicted on my map. Instead of it all being one color, I'm going to go to categorized. I want to have it show me the different levels of the water. So I'm going to go to categorized. The value, some vectorized layer just made, and I want to categorize the layers. I'm going to look on the DN, that DN that it said make sure it still had. You want to do it by DN. And then I'm going to go to classify. So what it does is it creates the same layers I had in the reclassified raster, but now they're a little easier to work with. So I've got 0, which I'm going to change the color of because I want it to be blue. Let's make it blue. 1. I'm just changing the colors of each of these things. Let's make that light. I need light blue. 2 meters. So I'm just getting my colors set here so we all can see. So what I'm doing is I'm going through here and changing each of the color to a different, deeper color so that we can see what it all looks like. And we don't need the other ones, and we don't really need number 4. That 4 doesn't mean anything because it's like everything above 3. So we'll just stay with 1 meter, 2 meter, 3 meter. I want to change to 0. This one's too close to the same as 3. Let's make that one. There we go. Okay, so what I've done is I've taken this vectorized layer, I've restyled it a little bit so that I can see the different colors that make up these flooded areas. And now we can start to look at what's flooding. Like if there was, if sea level rise happens, which they say will happen here in Halifax, they say that we're going to have up to a 3 meter sea level rise. Like the water is going to come up over the next few hundred years. But sea level rise is only part of it, and that's the static rise of the water. There's also, like, when you have a storm and you get those waves, you get a big storm surge, and that wave is standing up a meter or 2 meters of a wave, and like, okay, if the ocean goes up a meter, that's fine, it doesn't flood anything. But when that 2 meter wave comes in, now you're inundating these larger areas, and like this is the impact of water rise and waves for where I live. So we can look at that. You can start to see the areas in the lighter will be the first things that'll be impacted. The darker areas are going to follow. And you can see which buildings are starting to be impacted along the way. And then where it ends, like what buildings are safe too. Okay. Now there's a couple more things we're going to do just for fun to give us an idea of how this all looks. And we're going to do process using our processing tool. Before we do that, we're going to go over here to this side. We're going to go to our building layer, the Halifax building layer that we made. Is there a question in the chat? Terry asked, does it show rising water table predictions? You can model rising water tables, and it's very similar to what we are doing right here. What you'd do is you'd get a map layer of the current water table, and then what you would, if you have a rising or falling, because some people are dealing with falling water tables, is then you model that. You say, okay, so if this is our water table, what happens if our water table increases? And you can raise that up. But this is just surface water. I'm just doing surface water here, but you can do water tables. And for predicting it, you need to tell it what to predict. The thing about this mapping software is you need to tell it what you're looking for, and then it can help with your prediction. But until you tell it, it doesn't know. There are fancier ways you can, with this program, say, if it rained 6 inches, what would flood? If it rained 10 inches, what would it flood? If it rained, 20 inches, what would it flood? That's a little more complex. So you can do that too. There's a number of steps you have to take to make that prediction, because there's more calculation you need to do. But for static rise, we're just doing like static rise. You can do water table or surface water like we're doing. Okay, what I'm gonna do now is I've got buildings. All the buildings are sitting here, and it's just a footprint of the building. I want to say, well, how tall is the building, and how is the water rising going to affect that building? Tall buildings will stick out above. Short buildings might get overtopped. Like, I want to look at that. So I'm going to do another step to get an idea about the buildings. So I'm going to go to Halifax building layer. I'll have that highlighted on the left. Hold on a second. Getting dark where I'm living. I'm going to make sure the Halifax building layer is selected. I'm going to move over to processing. I'm going to use this fancy little tool that I like called zonal statistics. So at this point, you could just stop. You could have like your map. You've got your buildings, your water. You can see where they interact. You could stop there. But we're going to go one more step. We're going to go to zonal statistics. And zonal statistics is a tool where we take information from one layer and we apply it to another layer. So our input layer is the Halifax buildings. So that's the one that I want to have more information. The raster layer that we're going to get information from is that DSM, that surface model. The DSM, remember, is the top of things. So my building model says what the footprint is. And then I'm going to take the surface model that says how tall the building is. And I'm going to put these two things together so I know the shape of the footprint and the height of the building. So we're going to make it, we're going to have the raster layer be my DSM. Output layer, I'm going to have this be Z underscore for an output. That's where it's going to be saved. And then the statistics calculate. The statistic that I want is the mean. What is that kind of average height of these buildings? So it's got the mean, so that's the statistic I want, and we will run that. Take a moment. Now we're waiting. We got a question in the chat, maybe. Let's see. Here says also applies. Oh, what does Z mean? Z is just a letter, and it often in mapping, Z is often what they mean by height. Like it doesn't have to mean that, but it's kind of the convention. Z, and then mean is the average of the space. So the DSM is going to look at each building footprint. So like a building is kind of the square on the page. And what you said is, I want to know the average height of that square. So it looks at the DSM and looks at the footprint of the square and says, what are all the elevation numbers at that spot? And they're all about the same. You know, one might say 20 feet, and one might say 20 feet, 6 inches, because there's a little like, you know, heater vent on it or something. And then maybe there's one that was like 20, you know, 5 3/4 feet because there was, you know, a skylight. So it takes all the irregularities of the roof and just averages them out and says the average roof height of this building is 26 feet. Or the average roof height, so the mean is the average. So what's the average height of all of the kind of elevations in any given footprint? And then it says, it just then makes the top of the roof flat. So if you had a pointy roofed building, you know, you'd say, what's the average? It would be somewhere around the middle. So it wouldn't give you the terrain of the roof. It would just be like, oh yeah, so about halfway up the peaky sides would give you the average of the building, just to give you a sense of the building site. So it's Z is height, Z is just a letter to mean height, and then mean just is what's the average in that square. Okay, which is handy because once we do that, we get our zonal statistic done. We're going to, again, look at highlight this one, go look at our styling for it. And this one we're going to do something different with. We're going to go here on the left-hand side. You have all these things. You've got the little paintbrushy thing. You've got ABCs. Then you've got this cube. We're going to go to that cube. This is our 3D view. It's like, how do we make it look 3D? And we're going to adjust from no symbol to single symbol. And then in extrusion just tells us how do we want it to, what part of this layer are we wanting to determine the height is. So next to extrusion, there's a little icon here. It looks like some lines. We'll click on that, and we're going to do it by field type. And the field type is that Z mean. Basically, it says we want to determine the height of the building not by any of these other things that are in this list. We want to use the Z mean to determine the height. So once we've done that, we now have attached that height to the buildings. What that means for us is now we can go from this map, which is useful, this map where we can kind of scroll around and be like, okay, so the Halifax Museum of the Atlantic is gonna flood at 1 meter, and at 3 meters it'll be totally surrounded. The Victoria, Marquis is gonna flood heavily in the middle on one side, and the other side is gonna be drier. So you can look at where your flooding is going to happen, which buildings are going to be impacted most. Which ones, like this one's very interesting. Like the inner courtyard of this area is actually going to be dry. Like it's not at 3 meters, it's not going to have water in it, but it'll have a wall of water all around it. So you can go from this useful map to doing some other cool things. Like we can, with QGIS, we can start to do project it into a 3D map. So you can start to see, okay, what are we talking about here? These small buildings will be underwater. These larger ones are going to, stand out a little bit. And you can just move along the coast and see what's going to be sticking up, what's going to be covered, what's going to have the most impact as we go along. Okay. So I'm going to stop. Okay. If you've done all of this work, making these maps, you want to make sure you save it at this point. Like, okay, because you've done great work and you'll come up here, come back up here, you go project, you'll save as or save it, you'll save your file, and then you'll have it for later. You can shut your program down, open up again, you get it. So this is, there's many ways to make flood maps, but this is one way. It's a fairly straightforward way to make an easy flood map using QGIS. Now, I'm going to stop and take questions about this or any of the other things people are wondering about at this point. And you can just unmute and ask your question.
I have a question, Irene here.
Yes, Irene.
Yeah, so thank you for that demo. Is it possible to change the 3D view based on, okay, I'm sorry, let me re-ask.
Okay.
You can expand the flood levels because you differentiated 3 different levels, 1 foot, 2 foot, 3 foot, for instance. Now, if you are aware that it could be higher than that, let's say a tidal wave or a typhoon coming in, and you're aware it has a potential of 10 feet.
Yep.
So now you can extend those layers to up to 10, 15 feet just to see how far would that go inland and impact the buildings. So
Absolutely.
okay, so then you have the building heights, which are automatically in the system, but you have to bring light to that because you are suggesting that you have to tell this program, okay, it's going to be a specific. I want to see the heights of the building in 3D. It knows what those heights are. It's averaged out the average height with whatever that Z-mean thing is.
Yeah.
So if it's the wave goes over the building, how do you know? Is it going to be covered in the color blue that
Uh,
is supposed to be covered in?
yes.
Because the
So
buildings are still yellow in the shoreline that you just said should be covered, or did I
yes.
get that wrong?
Yeah, so there's two things to know about kind of how this sets up, and that
Uh-huh.
is this on the left-hand side of our layers, it's like a stack of papers. Whatever is on the top of this stack is what you see above the things underneath it. So if I were to move uh, let's say I'm going to move this out of the, I'll take this one off. But if I took vectorized, which is the the blue layer that we have, and I move it above buildings. So I drag it up here.
Changes the priority.
Oh, where did it go? Where did my vectorize? Oh, it got moved off. Yeah, it'll change the priority it sits in the layers, and it'll show you where what
Bingo.
buildings it covers. And it doesn't. I've not asked it to say only cover by the height of the building. But right now, just like will it cover any of the surface? So it just moves the layer. If you want to see actually the relation between these two layers, this is what we do. So I'm going to move that vectorize back down so it's so we can see this, and go back to this one. Oh, guys, see your hand. We'll get you in 1 second. Okay, let me come back to my. Trying to get back to my 3D map here. Come on, open up. Is it hiding somewhere on my computer? No, that's it. Ah, there we go. Okay, what we're gonna do right now, I have it set up so that the nice thing about the mapping program is you have a lot of control over how it shows you what it shows you. So right now, I just made the color sit on the surface. If I wanted to see the height of the colors, I'm going to my flood area. And I'm going to go to the properties. So I just went to the properties of the layer that is the blue colors. And instead of being a polygon, which is the flat one, I want to use it extruded. So basically, I want to know the height of it too. And the extruding is going to be absolute. It's going to go from 0. And the height is going to be the dn. And
Can you define DN again? I
DN
didn't
was
understand what
the letters we were using to kind of do the height. It was what it automatically generated was DN, so I just left it. You could put anything else you wanted there, and that should. Did I? Oh, I chose the wrong layer. No, that should have been the right one. No, wrong one. Sorry, wrong layer. go back to polygon. No, that should have been it. Hold on a second. It should have popped up, but it didn't. Extruded, absolute, NDN features. There we go. Now you can start to see the levels of the water as it relates to the buildings. So basically, I've asked the program to demonstrate what the water as it stacks up. And it looks all blocky like this because we have told it, we haven't had it gradual. We've said like, you know, from 1 to 0 is just going to be 1, you know, from 0 to 1 will be 1, from 1 to 2 will be 2. So it kind of jumps up. We could have it be more gradual, but it basically says, you know, this is how it's going to, you know, come in and start to go around these buildings. So you kind of see the height around the buildings.
Got it. Thank you.
Yeah.
Interesting.
Yeah. So you just have to ask it the question. Olga, yeah.
Yeah, hi. Yeah, we're probably going to be more concerned about things like brooks, inland streams.
Mm-hmm.
I'm wondering, a simple question, I mean, is this all satellite driven so that the topography is absolutely current? Because, you know, with previous flooding events, I know that some of the topography has changed. So, you know, when we go and use any of these GIS tools, they're pulling in absolutely current satellite images?
No, what they're doing is, here, I'm going to come back to where I got my information. So in this case, the DSM and DEMs I were using were from 2007.
Oh.
So that one is accurate only the moment it did it. And ever since then, it's been shifting. So of course, some things aren't true because it's not 2007 anymore. Some of them, there are ones, let's see, up here. Here, there's another set that I could pull in from 2018. So there's another area, like depending on what I'm looking for, I might have to be really picky about which ones, like, is what I'm looking at, has it changed since then? The thing is, the way in which this data is gathered gathered by not just satellite. Satellites do lots of things, and different satellites take different images. So most of the satellites we have do not take elevation images. There's particular missions, shuttle topography missions, that the US has done a number of, and Europe has done a number of, that have done the whole globe a few times. The really, really accurate ones you're going to find for your area will be LiDAR based, and they will be done by either companies or the cities or townships or states. And they will fly over with a drone, and they'll take these elevation images. And then they won't take them again for a number of years, and then they'll fly over again and take them. So really, it depends on when the last time your local government, municipality, or companies will do it too, have taken high resolution images from drones. So most of it is, these days, the best stuff we're getting isn't coming from satellites. It's all coming from drones.
Oh, okay. Well, I mean, that, you know, like I said, we have these inland flooding issues. And I think in order for any flood mapping that we do, you know, it has to be current, because we anecdotally, we know that there have been new streams that have been created.
Yes.
You know, so, but that's all anecdotal. You know, we're just about to embark on doing some flood mapping, but, you know, we have to work with current data. And we're a small community. I can guarantee you our municipality is not flying drones and capturing.
Well, you know what? The price of doing drone LiDAR, photography has gotten very cheap. So the ability for townships to do it, we're not talking thousands of dollars to do. Depends on your area, I should say. Depends on how big of an area you're doing. But like the price of this has really, really, really become much cheaper. And a lot of municipalities already have drones for all sorts of stuff that they do. And it's about the cameras that they use. It's about how the cameras work. So a lot of them have the technology already to do it. It's just convincing them they should do it again. Because and there are companies that have the technology to do it. Like the technology to do this, and the frequency in which we are getting high resolution imagery of our local landscapes is much more common than you might think. The question is, how do you get a hold of it? Because maybe the municipality does it, maybe the state does it. There's a place that I lived that the best LiDAR data that we had was coming from the Department of Defense, because they were doing like war games, and they had like imaged a huge area, and that was all public, but getting a hold of it took a little bit of like hoop jumping to get it, but it's out there. So if you don't have really current data, encourage your local municipality to get the data. Like they can do it, and it's not that expensive compared to many other things.
Yeah, it's possible we can wrap that up into a grant application.
Yeah. And people and municipalities use this information for all sorts of things. So they'll do it for stormwater management, for safety and security stuff. They'll do it for mapping and planning, for lot line stuff. Like they map all sorts of things all the time. Like planners, your city planning department, and not all the information that you want is publicly available on the website. So sometimes you're like, oh, I'm looking for this, I can't find what I'm looking there, and you got to get a hold of them and be like, I want the thing, and they'll be like, we got the thing, but you got to tell us why you're going to use it, or we're not going to give it to you. So sometimes you have to convince them to give it to you.
Thank you very much.
Yeah. Yeah, other questions? Let's see in the chat. I see. Okay, Hannah's hopping off. Yeah, we'll be sending out the recording of this. I'll have a little tutorial that'll kind of walk you through the steps that I use to do this. And if you end up doing this in your own community and you get stuck on the digital end of it, feel free to reach out. I'm always happy to help. Or you can come join me for our GIS class so that we kind of work through how to do this and much more. Yeah, thanks for coming. Sophia, nice to see you.
Charles, when did you say the recording would go back out? A couple days, few days?
The recording should be out in a couple days. It takes a little time to get it processed, but usually we have them out within 48 hours.
Awesome.
If the recording went well, I should be able to have it out by tomorrow.
Great. Thank you.
Yep.
Thanks for this.
Absolutely. My pleasure. If there's no more questions, I think I'll wrap up today, and we'll get everything out to you in the next couple of days. Have a good day.